Okay, so we're doing 12.6, which is cylinders and quadric surfaces. Okay, so this is a little bit of a pain. The problem is that everything we do, I mean, you just have to picture a Math 180 class, but put into 3 dimensions is kind of where we're going. And so where there were curves and there was graphing and there were mins and maxes on curves, now we're doing it on surfaces. Same stuff, mins, maxes, graphing. Not tangent lines, but tangent planes. And all of that needs to happen on a new collection of things. Some of them you're going to be expected to be able to graph. Okay, so let's see what we can do here. This is not a lot of material here, but the graphs are not great. So let's just do our best here. So we're going to start with cylinders. This is basically a plane curve that's projected along a perpendicular axis. So a plane curve extended along an axis perpendicular to the plane. Okay, so if the plane is one of the 3 coordinate planes, then the cylinder is just an equation in 2 variables. And the 3rd variable is unconstrained. Okay, so that's a cylinder, and it's not necessarily a circular cylinder. So it can be circular. So we do that first, the circular cylinder. That's just x squared plus y squared equals a squared. And the point is, it's a surface now. It's not a circle anymore. Because the context is 3-dimensional, you have to realize this is unconstrained in Z. Okay, so yeah, you can draw a circle. That is not one. Oh my Lord. 3 tries and I get it. Okay, so I'm just gonna stretch this a bit. Okay, and then I'm gonna put some coordinates on this. I'll move the ellipse over to its location here. Center it on that, like that. Okay, I think I am gonna get rid of the shading. And then if it's x squared plus y squared equals a squared, then it's just a circle of radius a. That. But then again, when I say it's unconstrained in Z, that means that that circle can be projected up. I have a correction to do on this real quick. It's not, just very briefly, I want to snap it so it's horizontal. It wasn't horizontal, it was bugging me. That's better. Okay, and then I'm going to make a copy of that and just put it up higher like that maybe. Okay, and then give it sides. So this is what it means to be unconstrained in Z. I might do some snipping to make that line in the back on the bottom a hidden line. So hidden lines are usually done with dotted lines. So I'm gonna just make, do some snips. Like that. Okay, so any questions? I hope you can see that. Okay. So that's the simplest of the quadric surfaces, just a circular cylinder, but it's not the only type of cylinder. Cylinder just is unconstrained in one of the variables. If you want, you could put sides on the. I don't know if coloring will help you, but you know, if usually what I do, it's kind of easy on an iPad where I would shade the front in one color. And then usually I come back and do the back in a different color, and that allows you to see it maybe a little better. That's usually kind of what they do in the textbooks. This is a little rough the way I'm doing it here. But if I shade the back, like kind of like this, then I hope it helps. And it allows you to sort of feel like, okay, I'm looking down inside of it now. Okay. So that's one way you can color these out. I don't know if that helped or hurt. I'm sure there are other things I could do to sort of enhance it. I'm not sure. I don't know. Anyway, I think I'll move on. Let's do a parabolic cylinder. Okay, so what you want to do is think of a parabola. And again, this could be in the XY plane. So I could do like y equals x squared. So let me show you. I'm just going to draw a y equals x squared parabola. But the y-axis goes that way. And so it's a little harder to work with. Oops. So let me just see if I can pull this off. First of all, I'm going to do some guidelines here. So I'm copying the x-axis. Okay, I'm going to put a copy right here. And I want my parabola to sort of go up and touch that thing. So now I'm going to draw a parabola. And who knows if this is going to look any good. Yay. Okay, and I'm just going to try and make the distances right here. Oops. Okay, just kind of tweaking it. That's pretty good. And then what I want to do is do sort of a, I'm going to make a kind of a copy of all that at a higher elevation. So maybe I'll do a z-axis now, just vertically upward. And by the way, this is just y equals x squared. But there's many cases of parabolic cylinders that you could do. So this is not the only one. Okay, and I'm copying part of this. I'm going to just paste it up at a higher elevation, sort of like here. I think that's what I want. And I'm going to erase some of this, but currently I'm going to drop some guideline or drop some lines here like that. Yeah, I don't like the way that looks. So hang on a second. I have to move my other stuff. So this is a guideline that I am going to erase also. Oh, that's not bad. That's pretty good. Okay, so I'm gonna erase some of this, and I'm not really satisfied. So I'm going to do some more. Now I'm starting to connect things on the surface. So I'm going to draw verticals on these edges here. And now I think I'm going to get rid of my guidelines. Okay, I'm probably get rid of that too. And now I'm just looking at a surface at this point. I'm going to add another perpendicular to this real quick. Or sorry, another vertical on the back edge. There is something right there that I want to put in. It's hard to see it. I can see that how that green line works there. So I'm going to erase, that's a guideline. I'm going to erase that now. Okay. All right, so I hope you can see that. And so that's, again, it's sort of a reason why this is sort of simple is just because you know how to graph parabolas. So when you extend them in 3 dimensions, it's not, I mean, it's a bit of a stretch, but it's not a huge leap. So that's sort of the front. And then if I had to do the back, I'm going to try just a paler shade and see how that looks. I don't know. You see it's a little, oh, that's horrible. Trying one more time before I give up. And I don't know how you would do this kind of shading on a piece of paper, but you can kind of see, helps a little. Okay, any questions about that? That's a parabolic cylinder. You can have any kind of cylinder. It's just an equation in 2 variables. And you guys are real experts at equations in 2 variables. So there's not much else to say. You just extend it along the 3rd axis. Okay, any questions about that? Yeah, thanks, Piper. I see. I haven't done attendance, but I'll do it before you go. All right, now the harder ones. Let's go ahead and first of all, I guess I should define what is called a trace. And I'm just going to jump into this new section. I'm going to call this equations in 3 variables. Okay. Just the term trace. That's where you set one variable to a constant to make a 2-dimensional curve to help you draw the surface. So I'll say setting one of the 3 variables to a constant. to make a curve. That helps you draw the surface. Okay, so I usually, when I'm drawing drawing these graphs with 3 variables, I usually just try and pick good traces. And so let's see what this comes out as. Little example here. Let's do y equals x squared. I know what that looks like. But then there's another part that is z squared plus z squared over 4. Okay. And now you sort of play around with, well, what variable should I set to a constant? I think that if I make z 0, that's super easy. So here are the traces. First, z equals 0. Okay, so we do that becomes y equals x squared, which is a parabola. Okay. The z equals 0 plane. This is z equals 0 means that's the xy plane. Okay. And so just as easily, we would do x equals 0. Okay, and of course that'll be y equals z squared over 4. Okay, again, a parabola. Now where x is 0, that's the yz plane. Okay. Now, those are just sort of, to me, really obvious traces to do by setting x and z to a constant. But it doesn't make sense to set y equal to 0. Notice the values of y have to be positive. What would be a good value to set y to so that you ended up with a curve in x and z that was just super obvious? So give me a trace. Y equals what?
4, maybe?
4 would work. Absolutely would work. It's a little more complicated than what I was thinking of. What's the simplest thing you could do so that you would know what that graph was?
1, y equals 1.
Yeah, y equals 1 just gives you, I'll write it this way, x squared over 1 plus z squared over 4 equals 1. That's an ellipse. Okay, does that make sense? So, so what I would do is try my best to draw 2 parabolas and an ellipse in a way that makes some sense here. So I'm just going to start by drawing my ellipse, and then I'm going to set it in the right location. Okay. So it takes me a second to get a good ellipse. And that was a good one. First try. Okay, so that's the ellipse that I need to draw. Okay, I'm just going to build the graph around that little picture there. And I'm going to get rid of the filler. Okay, so there's my ellipse. Now I need that to be where y is equal to 1. Okay, so what I'm going to do is I'm going to make a y-axis just kind of go straight through that. Okay, so here comes my y-axis right there. Okay, so somehow I'm going to try and target the middle of the ellipse. I don't know how I'm going to do that. How do I do that? How do I do that? I think I know what to do. Okay, that's the center of my ellipse. Now I'm going to draw some other lines here that cross through that. So you're going to see what I'm up to in a second. This is just a plain vertical. So I'm basically putting a little coordinate system in my ellipse like that. And now from there, I can move my y-axis back this way. So this is what I was trying to get, the center of that ellipse. And then what I have to do next is draw some parabolas. And actually, I'm going to do a little more cleanup work here. Okay. Now I need parabolas. So, and I'm going to do this pretty free form, but I know that in the XY plane, I just need a y equals x squared parabola. So I'm going to just draw a y equals x squared parabola best I can like that and see if it gives me one. Yeah, that looks pretty good. Okay, and I'm just going to tweak this a bit so that it touches right there. Okay, so that's y equals x squared. I need one more parabola. That would be y equals z squared over 4. So here I am. I'm going to try one more parabola, see if I get lucky here. Like that. That didn't work out very well. Try it again. No, that's no good. Good thing about this is I draw my parabola and then it lets me move it around. So that's what I'll do. What's that? That's good. I like that. Okay, now I still need an x-axis and a y-axis. So the parabolas touch at the origin. So this is my origin here. I actually want my x-axis to go parallel to that other thing I drew. So I'm going to steal it. I kind of have an x-axis inside the parabola. Then I'm going to steal. And paste it right there. That's my x-axis. Z-axis needs to be vertical. I don't have a lot of room here, so I'm sort of fudging it. Oh, and I need to move both of those. That's funny what I did. The shape needs to be, that's the origin at the bottom of the parabola. So there's just a little lapse there. Okay, and I think I'll cut off part of my y-axis because it's too long. So something like this. Okay, now I have to convince you what all the elements are here. Okay, so this top trace is what it's called, was where x is 0. And so that's y equals z squared over 4. Yeah. Okay, now this trace here is the ellipse. So that's x squared plus z squared over 4 is 1. And I don't know if you can tell, but this distance, this vertical height has to be 2 right here. Let me zoom in on that. So this height right here has to be 2, and down below has to be 2, because that's a 2 squared under the z. Maybe I'll make it a 2 square in this little description right there. Okay, and under the x squared is just sort of an invisible 1 squared. So I have to go 1 to the left and 1 to the right in the x direction. Okay. This is also occurring here at the point where y is 1. So this is all really compact. I think I'll switch colors just to make this more separate. So this is going to be where y is 1 there. And the only thing I haven't labeled was the other parabola. So this parabola that's sort of in the XY plane is y equals x squared. Okay, and so this guy right here is an elliptic paraboloid. Well, why? Because when you do cross sections, when you slice it, you get either parabolas or ellipses, depending on how you slice it. Okay, do you guys have any questions about that? Isn't that lovely? And I'll go ahead and say you ought to be able to graph one of these because this is actually pretty simple compared to the hyperbolic paraboloid, which is the stuff of nightmares, is what it is. So I like to do these paraboloids on exams, FYI. So and when I say you ought to be able to do it, I mean on an exam. Okay. Any questions about that? What's another? I'm trying to do the stuff I'm very likely to do. Oh, let's do an ellipsoid. This is ellipses in every single cross section. So, any questions on this before we go on?
So if it's on a test, are you just going to give us the equation and then just have us graph it?
I might say, here's an equation, find the volume. And so finding the volume of that solid that I drew, it could be like a half a potato, right? You cut the potato. Yeah. So find the volume of half of this potato is the question on the exam. And all I do is I don't give you a picture, but I give you the equation. Okay, and the limits on y goes from 0 to 1, and that makes the potato. But the question is really, if you can't picture it, can you set up the integrals for a triple integral to find the volume or the mass of that solid? And the answer is no, you're not going to be able to set the integral up if you can't draw it, because the limits on the integral are basically the surface. And so I'm going to tell you which ones I expect you to be able to do on an exam. Most people aren't going to very quickly draw a hyperbolic paraboloid because it's just hard. But these elliptic paraboloids are super easy compared to some of the others. So I'm trying to tell you which ones you ought to be able to do quickly on an exam. All of the ones I'm talking about today could come up in homework. Okay, but also GeoGebra. There's a 3D grapher for GeoGebra, which I'll show you before we're all done here. Okay, so let's try the hyperbolic paraboloid. And I almost feel like I sort of want to show you the picture first, because I don't tend, oh no, I said I was going to do an ellipsoid next. Forgive me. Let's do the ellipsoid next. Okay, so I'm going to do this in general. So this just looks like an ellipse. The equation looks like an ellipse, but there's a third variable. You know, I'm going to put a equals 1 out there. Okay. But the z part looks just the same. So you can see that if for the traces, that if you make z equals 0, it's an ellipse. And if you do y equals 0, then you get x squared over a squared plus z squared over c squared equals 1. It's an ellipse. And if you make x equals 0, that's the third trace, then you're going to do y squared over b squared plus z squared over c squared. It's an ellipse. So these are all ellipses. Okay, so again, that's easy, relatively speaking. So I'm going to try one more time and do a nice picture here. Oops. It's going to be too big, I think, but I'll deal with that. Oh, when the time comes, I'll deal with that. Okay, and then I'm going to clean it out so it doesn't have a fill. Okay. And basically, I'm doing 2 more ellipses. Okay, so I'm going to do maybe an ellipse that goes sort of like this in the x direction. I'll probably shrink that down quite a bit so that it kind of just touches there and touches, well, it's too big. The whole thing is just crazy. I don't like that. Hang on. That's not right. I just take it all back. Okay, so, oh my goodness. Okay, so that was just wrong. That was just wrong. Okay. Let's try again. Rotate. So there we go. Snap it. And then what I want to do here is, once again, I'm going to get rid of the fill. Maybe make this a little thinner, like that. And try and center it on the same spot. Okay. Okay, now, trickiest part is recognizing that my coordinate system's got to go in here somewhere. And so I'm going to make an x-axis coming out like this. Maybe, yeah, I'll probably center it in there like that. Now I've made this so that it's probably easiest just to draw the y-axis, go right down through the end over there. Oops. Okay, and of course the z-axis will go straight up. But I need one more ellipse, obviously, that just goes around the whole thing. So I'm just going to do that. And then I'll make it work. So let's rotate. It needs to be rotated. Okay. Okay, that's pretty good. So probably easiest way to deal with the three-dimensional effect on this one is just to hide the lines in the back. So here what I'm doing is I'm just going to go ahead and make the back lines dashed. I don't think shading is going to give me any advantages on this. So the back lines are that one, which I'll make a dashed line. And this one, same thing. And then I guess the last thing I would do is label things. So X, the axis length for X goes out to A. So maybe I'll do this in red. See, under the X squared, you've got an A squared, right? Because I'm having a little trouble with my iPad right now. It's been glitching out for some time and I don't know why. But I'm gonna have to kick out of here for a sec and see if it starts working. Okay, so forgive me, you guys, I'm gonna kill this program because I've just had it with all the nonsense it's pulling. See if it works now. Okay, that works. Okay, it doesn't work. Okay, so what's going on? It's gonna take me a second to figure out why my stylus is not responding anymore. I think it's dead. I charged it. It's not dead. Yeah, my pencil died. That's what's wrong. Okay, so we're going to take just a 2-minute break. It goes pretty quick. I've been teaching all day on this pencil, and I guess it just died on me. So feel free to take a breather for 2 minutes if you like, and but it's only going to be like 2 minutes. When it hits 22 after, I'm going to start up again. Okay, so we're back here. I just wanted to put in the x-intercept up in front here would be A. The y-intercept on the end there will be B. And of course, up on top, Z is C. Okay, so it's 3 ellipses. And that's the easiest way to draw this thing. Okay, are there any questions about that one? All right, y'all. I'm going to go ahead and try and freehand a hyperbolic paraboloid. And so this is a little bit harder. And so let me, if you want to follow along and try and do this as well, be my guest. This is one I probably wouldn't give on an exam. No, that didn't look right. All right, so this one goes from here to here, another parabola right there. And then, how's this look? I don't know how this is looking. I'm sort of freehanding right now. Okay, so what you're gonna have here is we're gonna have sides that kind of come down like this, and like this. We are gonna have a parabola. So I'm gonna raise this middle up a bit. Let me mute whoever is making all those noises. Go. Okay, I'm going to do a little tweak here because I think that goes down too far. I may be sorry, but then this point, I need a little parabola going this way, kind of like that. To there, maybe. Part of that's going to be hidden. And then I'm going to do another parabola going like this. And this is going to go over here somewhere. Oop, that didn't work. Boy, this is like one of my worst attempts ever. Okay, that's the way it goes. Let me just take a photo of one of the ones I've done here. Now let's keep going. I just want to clean up a bit before we start labeling things. Working on a little hidden line removal here. Okay, so this guy has got to be dotted. This guy has got to be dotted. Okay, so some of this is just too long. I don't know how it got sort of carried away with itself. So right now I'm going to try and just kind of trim it back a little. Maybe like that. Okay, so what you're doing is you're drawing more than one hyperbola here. So let's see if we can put a coordinate system on this thing. I'll go to black for that. The origin is right at the crest here. So I'm going to have a y-axis coming out this way. And my x-axis is going to go that way. Okay, and then z, of course, will go up. Okay. Now, this trace right here, let me see if I can add some traces to this. So this one here is going to be z equals negative x squared. So that's a downward parabola in the xz plane. I am going to tweak this other parabola that's going up. I'm going to do just a little modifying to make it look a little better. Like that. Best I can. That guy right there is z equals y squared. It opens upward. Okay. That's in the YZ plane. Now, up where z is 1, we're going to have these traces here. Oh, by the way, and the equation of this is, again, this is a hyperbolic paraboloid. Okay, the equation is z equals y squared minus x squared. Okay, and so when you do the traces, if you do x equals 0, that's just going to be z equals y squared, which we drew. Okay, if you do y equals 0, oops. If you do y equals 0, you get z equals negative x squared, which we drew. Like that. If you do z equals 1, then you get y squared minus x squared equals 1. That's a hyperbola. So you can see we're getting parabolas. These two guys are parabolas. Okay. Or hyperbolas in our cross sections. If you do z equals negative 1, you get a different hyperbola. Look at it and you'll see it's y squared minus x squared equals negative 1, which is the same as x squared minus y squared equals positive 1. Okay, so that's this. Let me label both of these. So up on top where z is 1, we have y squared minus x squared equals 1. Like that. And down on the bottom, the last trace is x squared minus y squared equals 1. And that's the elliptic, sorry, the hyperbolic paraboloid. Let me just show you GeoGebra 3D. So it's super cool because it's just really smart. So class is almost over, but I'm going to pop over to GeoGebra. Let me take a sec. Okay, so obviously I didn't take roll tonight, so don't worry about that. But let's do, I always just type GeoGebra 3D and it takes you to the 3D grapher. Okay, GeoGebra 3D. And you can type any of these in. It doesn't always work perfectly, but like if you do the very first thing we did, we did the cylinder. So if you do like x squared plus y squared, and then say equals 4, that's that cylinder we drew. Okay, and it just sort of extends up forever. Super cool. You don't have to solve for a variable. The gray is the XY plane there. Okay, so I'll delete that. I don't think you should, yeah, you can do more than one graph in a picture if you want, but I'm going to pass on that and not complicate things too much. Oh, cool. Okay, next, the second thing we drew was a parabolic cylinder. It was just y equals x squared. So there's the cylinder, but remember, where'd it go? I lost it. Okay, I'm gonna have to delete that and do it again. It was there and then it finished. So one more time, hopefully that won't happen again. Y equals x squared is that. I don't know why what that plane is there. So it's not here. Anyway, so I've got that. Y equals x squared. Okay, that's the red one. I don't know what the blue is. I'm not even gonna try and figure it out. Okay, I'll delete that one. I think I'm gonna refresh this page because it seems a little glitchy right now. Okay, and then we did the elliptic paraboloid, which was y equals z to the second over 4 plus x squared. So here's the elliptic paraboloid that we drew. And then the big grand finale, let's go ahead and do that hyperbolic paraboloid that I did such a horrible job at. Let me delete this and finish it off. The last thing, I didn't do the ellipsoid, did I? But I'll skip that. That's pretty obvious. Let's do z equals y squared minus x squared. Like that. It's kind of big. So I need to zoom out, and I honestly don't remember how to zoom out in GeoGebra. I think you grab the axis and you drag it somehow. No, that didn't work. So the graphs here, I forget exactly how to pinch and zoom, but there's a way to zoom out on these.
There's a magnifying
corner.
glass on the
Yeah.
bottom right.
You guys know this stuff. Yeah, but look what it's doing. It's not doing what I want. So what I need to do is tell it what the domain is for my variables. I'm not going to figure that out right now, but it sounds like you guys will be able to play around with this and get some nice graphs out of it. So GeoGebra 3D, I'll try and remind myself how all this stuff works. For now, I'll see you guys, today's Monday. So I'll see you on Wednesday, and we'll be talking about your test next week as this gets closer. It's next Wednesday, remember. Okay, see you guys.
Thank you. Have a
Thank
good
you,
night.
Professor.
Thank you, Professor.
Bye, Professor. Did you take roll, Professor?
No, I didn't take roll today again, like a fool. I'm sorry.
Oh, okay.
Have a good
Um,
night, Professor.
Okay.
Bye.
Bye. Professor.
Oh, bye, bye, bye. Right, so we're doing a hyperboloid of one sheet, and these are the three traces. This is a hyperboloid of one sheet because it's really one surface, as you'll see when we graph it. But when we set x and y to a constant, you can see we're going to get an ellipse. So let's go ahead and draw this ellipse where z is 0. So I'm just going to kind of quickly just do myself a sketch of an ellipse. Maybe get rid of that fill. Okay, so let me see. I've got x squared over 4, y squared over 9. That looks great. So let me go ahead and try and do a coordinate system on this. I'm going to move this in a sec to there. Okay, I think I'll go ahead and put on a z-axis at this point. X squared over 4 plus y squared over 9 equals 1 means that right here is 2. Right there. And this is 3 on the y-axis. Like that. Now, when x is 0, I've just got a hyperbola in the yz plane. And I don't know about you, but I always drew hyperbolas by drawing diagonal lines first. So let me put up my ovals a little higher here. So I'm going to make copies of this little oval and put one up high and one low, and you'll see why. I'm not sure how to make it, but I'm just going to make this bigger. Make sure it's level. That looks good. And then center it on here like that, and probably do another. Something like that. So I'm in a little trouble. There we go. Okay, now my hyperboloid, right now I'm going to focus on this hyperbola here, y squared over 9 minus z squared equals 1. So that's a hyperbola that opens along the y-axis. So I'm going to do my best. What I think I'll do here is I'm just going to draw the arc, and then I'm going to shape it to this graph. Okay, so here I'm going to move this around a little bit like that. And now I'm just, that didn't work. I think what I have to do is just set it on here and then move the other point, unfortunately, like that. That looks pretty good. And then another one just like it on the other side. Okay, so that hyperbola is supposed to be y squared over 9 minus z squared equals 1. This guy right here. Let me do a different color there. And that's in the YZ plane. Okay, any questions? And then there's one more hyperbola in the XZ plane. That'll be the hard one. And so I'm gonna have to be a little more careful with this, but I'll do my best. So I'm gonna copy one of these curves again and try and bend it to my will. Well, that looks pretty good right there. And I need to extend my x-axis to the back. Just temporarily. And I'm going to extend that curve one more time. Something like that. Okay, so I think I'm going to get rid of as many of these guidelines. I can get rid of that. Okay, so that hyperbola in the XZ plane, this one is going to be x squared over 4 minus z squared equals 1. That's this guy. Okay, so that's the hyperboloid of one sheet. You can do all the stuff that we did last time by trying to hide hidden lines and stuff like that. It's a little bit troublesome to go through all that. I'll do a little real quick. Just looking for the hidden lines right now. And I'll make them dashed. What I just did. Okay, so I think I've got all my bases covered here. You could hide the axes, but I'll save you the time and not do that. Okay, you guys have any questions about the hyperboloid of one sheet? Oh, and I guess I didn't put my ellipse in there, so I'll put that in real quick. So this ellipse right there is the x squared over 4 plus y squared over 9 equals 1. And again, I think that the hyperboloid is one of those graphs, whether it's one sheet or two sheets, that's probably the kind of graph I'd probably give you on an exam and not expect you to have to pump one of those out because it just takes a lot of time, as you can see. Okay, is there any questions about this one? All I have to do is take one of the plus signs in a one-sheeted hyperboloid and turn it into a minus sign, and I've made a two-sheeted hyperboloid, which I'm about to do. These are actually a little easier to draw. All right, so down below, we'll do a hyperboloid of two sheets. This is still an elliptic hyperboloid. Okay, so this one, I could take that same equation, but I think I'll use a fresh one and just do x squared minus y squared minus z squared equals 1. And the point on this one is just sort of, with two minus signs. And I'm assuming you've got all the variables on one side and a constant, a positive constant on the other. Okay, so with two minus signs, oops, that's why we get two sheets. Okay, and then same thing up here, but we only have one minus sign, so it's one sheet. Okay, any questions? Okay, so let's look at the traces real quick. Z equals 0. So that is going to be x squared minus y squared equals 1. It's a hyperbola. Oops. Then if we do x equals 0, then you get negative y squared minus z squared equals 1. Tell me about that. Is that possible?
No, it's not.
Okay, so this is empty. There is no solutions to that. Okay, so this is kind of what's responsible for the tearing in the graphs. Okay. Into two sheets. Okay, if we do y equals 0, then we're talking about the xz plane. So if y is 0, you'd have x squared minus z squared equals 1. And that's another hyperbola. Okay, any questions? Now I want to try and think of a way to get a trace for a different value of x. So what, just to let you know what I'm going to do right now is I'm going to try and think of a number I could put in for x. So that I would get a circle. Okay, I'm thinking if this thing was a -9, I'd have negative y squared. Again, I'm putting a number in for x right now. I'm doing traces on x. And I want to get negative y squared minus z squared equals -9. So what I need is for x squared to be 10, which means I'm going to have x be plus or minus the square root of 10. Okay, which means x squared is 10. Okay. And so what you would get out of that is 10 minus y squared minus z squared equals 1. And that's going to get what I wanted, where I have a negative y squared minus z squared equals -9, which means y squared plus z squared equals 9. That's a circle. Okay, so that's what I was working really hard to come up with here. Two different locations where I get a circle, y squared plus z squared equals 9. Okay, so again, yeah, that's a circle.
Question, Professor.
Go.
Is there a reason why we want a circle over another shape, or is that just more
No,
convenient?
I just wanted a trace for x. You know, when it came up empty,
Mhm.
I wasn't happy that I didn't have a curve to draw on the YZ plane.
Okay.
So I'm trying to find, you know, the real problem was, if you look at this, the real problem was this guy, the negative y squared plus minus z squared, that's negative.
Mhm.
And this is positive. And so in my mind, I'm thinking, well, if this was negative, then the negatives would cancel out. So what could I put in for x so that it would come over negative? And so you see, I put in the square root of 10 here. I square it, I get 10, bring it over, I get a negative, and then everything's positive.
Got it.
I just wanted to trace with X.
Perfect. Thank you.
Okay, yeah. So that's the idea. And there might have been a better way to do it, but I'm pretty happy because that's going to be easy to draw. Although I don't know what the square root of 10 is. So let's just see here. Square root of 10 is going to be 3 point something, right? Is it 3.1 or something like that?
3.16.
3.2 then, right? Okay, not that I'm going to draw that precisely. Okay. Now, so here's a problem I have. I kind of want to be able to get a good view of that x-axis. So I'm actually going to have x go this way. So I'm coming around and looking down the y-axis right now. So I think my y-axis is going to be sort of pointing this way. So just think of this as we went around and looked at it from the other side. Okay. And what I want to identify is that square root of 10. So somewhere over on the right is the square root of 10. Well, negative square root of 10. And on the left will be positive square root of 10. Okay, and I know that I get to draw a circle there. So, but when we're looking at it at this angle, this is a circle in y and z. So I'll go ahead and put z up here. Ooh, I did not mean to do that. Okay, let me put my z-axis on here. Okay, and so I'm just going to try and draw a vertical oval that will essentially turn into a circle in a minute. Okay, let me make sure that's vertical. Looks good. Okay, so I'm going to snap that right to there. If I could get it to snap. That's best I can do. And then the other one. Whoa. I think I'm going to need some help with this. So I'm drawing a guideline right now. Oops. Something like that. So those are my two circles where x is plus or minus square root of 10. I'm going to erase that guideline. Now in the xz plane, where is that? I just have x squared minus z squared equals 1. That's just a normal hyperbola, but it opens along the y-axis. So I kind of need that intercept. So let's find the, on this x squared minus z squared equals 1 hyperbola. I'm just going to grab that. We can put it down below. I kind of want to know the x-intercept for that hyperbola. So that's when z is 0. So the x-intercept has z equals 0. So x is plus or minus 1. Okay, so I'm trying to figure out if this is square root of 3, then plus or minus 1 is going to be around here, negative 1, and a positive 1. Same on the other side, kind of like that. And then I'm supposed to draw hyperbolas. And what I'm going to do is I'm just going to do this. This is a hyperbola, but you can't see the whole thing, of course. Like that. And I'll paste it over here. Uh-oh. Something like that. I'll show the hidden line right now so that you can see that is as good as possible. Anyway, let me just put that hidden line right there. Right there. So you'll see this looking a little better with the hidden line there, so you can see where you're looking from. There is another hyperbola here that's gonna be super hard to sketch in. I'm gonna try and make this work. I think I'll do this first. So those are gonna be like that. And this guy is gonna go out like this. So, okay, so I'm gonna see what happens if I put this right here. And this is gonna go over here, and that's gonna go down like that, I think. There. That's the other hyperbola right there. Part of that's hidden, so I'll deal with that in a sec. And then we got one more coming up here, so let me put that in here. Like that. Okay, so I'm going to just hide the hidden parts. These dots are way too big, so I'm going to probably lose the huge dots that I drew here. And that'll allow me to clean up and fix a little. Yeah, I'll do a little cleanup now. That's good. Okay, so now I'm just doing the hidden lines. Okay. Okay, and then I would just probably label my hyperbolas and all my curves. So this curve, these two circles are x squared plus y squared equals 9. There's two of them. Okay, now the hyperbola here opening along the x-axis backward and forward, that appears twice. So this hyperbola is the one that's in the xy plane. So that's x squared minus y squared equals 1. Okay, same as this hyperbola. I don't cherish putting too much on here. This here also x squared minus y squared equals 1, same hyperbola. And then we have these big hyperbolas. These are in the xz plane. This one, x squared minus z squared equals 1. And same with this one. Okay, so again, that's a hyperboloid with 2 sheets. There it is. Hard to draw. I'll pause, let you guys catch up for a minute. You guys want more time? I'm
All
happy to
good
wait.
here.
You're good? Anybody else need more time? Okay. Then I think we can put that to rest. You can see these graphs are difficult. Let's just kind of scan through them again one more time. So basically, cylinders, these are good test questions. So you should be able to do this. Any type of cylinder. Okay, and I mean all semester long, you're going to be finding volumes and finding surface areas of these things. And again, the surface and the equation tend to be given, but you can't set up the limits for the integrals without being able to have a good sense of the graph. So cylinders, definitely good test material. I already said you ought to be able to do these, what do we call these here? This one here does not say, but this is the elliptic paraboloid. Oh, it says over there. Okay, so let me highlight a few things. Okay, so elliptic paraboloid, you ought to be able to do these on an exam. Okay, and not just opening on the y-axis, but any elliptic paraboloid. It could open up, down, left, right, whatever. Okay. Any questions? So I'll pull those. The ellipsoid, for sure, you ought to be able to do this on an exam. Because those are easy to draw. Okay, and of course, a sphere is a special case of an ellipsoid. I wouldn't hesitate to put a sphere on there. Any questions yet? And then I don't see myself giving you a hyperbolic paraboloid or the elliptic or the hyperboloid of one or two sheets. So I'm not going to put that note on these last three graphs. Okay, if I need you to see one, I'll give you the graph. All right. Other than that, I don't really have much else to say about this section. It's long. It's a little tough to do. I shouldn't say it's long. It's kind of short, but it takes time. And I'm just gonna, right now I'm gearing up for chapter 13. And if you want to squeeze in a question, the floor is yours.